Hello, today what we will be doing is learning how to graph equations from either the x and y intercepts or slope-intercept form. So y equals mx plus b, or from using the intercepts of an equation. This is the fun stuff. We're finally getting into some serious algebra. Now, the prior knowledge that we have to have in order to graph equations, remembering what the x-intercept is and the y-intercept is and how to find them. So the x-intercept is when y equals 0, and the y-intercept is when x equals 0. And how to find those out? For the x-intercept, make y 0, solve for x. To find the y-intercept, make x 0, solve for y, or identify it from slope-intercept form. So we need to remember about intercepts. We need to remember slope-intercept form when y is by itself. This only works if y is by itself. Y equals mx plus b. Then the coefficient of x is the slope. The other number hanging out there, that's the y-intercept. So that's prior knowledge. We also must remember vertical lines, how they operate. It's the same x. So it's an undefined slope. All vertical lines have the same x-coordinates. We have horizontal lines. All horizontal lines have the same y-coordinates. And the slope is 0. So vertical lines, undefined slope. Horizontal lines, slope exists. It is 0. So that is prior knowledge we have to remember. We also need to remember about equivalent fractions. The integer 3 is the same thing as 3 over 1. And we're ready to roll. So we're going to learn how to graph an equation from slope-intercept form. These are the basically instructions on how to do so, because it's super duper easy. So to graph an equation from slope-intercept form. If an equation is in slope-intercept form, it makes it very easy to graph. When you have the equation looking like y equals mx plus b, remember when we talked about what does m stand for? I said it stands for move. So what does the b stand for? The b stands for begin. So to graph equations in the form of y equals mx plus b, you begin on the y-axis at this number, and then you move, rise over run, for slope. Makes everything easy. So B is for begin, M is for move. Begin on the y-axis, move with rise over run. That is how you graph equations from slope-intercept form. So let's do a couple of examples and get you used to what this looks like. If I wanted to graph the equation y equals 2/3 x plus 2, I can see that this equation is indeed in slope-intercept form. Y equals mx plus b. So I can use the m and the b. B for begin, M for move. So I will begin at 2. Now what that means is I'm going to begin at 2 on the y-axis. So if I have my coordinate plane, I can begin the graph on the y-axis at 2. I will begin at 2. And where is positive 2 on the y-axis? It is right here. That is plus 2. So I begin there. Now the move part is the tricky part. The slope of this equation is 2 over 3. So what that means is I'm going to rise over run. I'm going to rise a positive 2, and then I will run a positive 3. I'm going to rise a positive 2 and run a positive 3. But from where? From where we began. So we're going to rise over run from our beginning point. So I will rise 2 from where I began. I'm going to go up 2, and I will run 3. And that gives me my second point. And now that I have 2 points on a graph, any 2 points makes a straight line. So I now have a straight line through those 2 points. I now have a straight line through those 2 points. I can draw my line through. Remember to draw your line through. Don't forget the arrows. I have now graphed y equals 2/3 x plus 2. Let's do another example. What if I wanted to graph the equation y equals negative 2x minus 1? This is where things get a little tricky. So let's recall that I'm working with a coordinate plane, and we can make your coordinates, make your tick marks on the axes. So looking at the equation y equals negative 2x minus 1, that looks like it's in slope-intercept form. I begin at negative 1. I begin at negative 1. So it's on the y-axis. I'm going to begin at negative 1 on the y-axis, and there's my first point. I'm going to move my slope. Now, what is the slope of this equation? The slope is negative 2. So how do I count rise over run with negative 2? I need to count slope. Remembering that slope is rise over run. What do I do with that negative 2? Remember equivalent fractions. Negative 2 is a fraction over 1. So when I move a slope of negative 2, I have a rise of negative 2, a run of 1. And that I know how to move. Where do we begin? We begin at the y-axis. And how do we move? A rise of negative 2, which means I will go down 2. So the negative means I'm going down 2. My run is 1, so I will move to the right, positive 1. And there is my second point. There is my second point. So 2 points on the graph, make a straight line. I now know how to graph my line. So remember, for graphing, we connect through and we put our arrows there. And we have now graphed that equation. So let's graph another example, one of my favorites. It's a very important equation later on in math. We're going to graph the equation y equals negative x. Once again, we have our coordinate plane set up. We're going to see what happens with this equation y equals negative x. Y is by itself, so it is in slope-intercept form. Y equals mx plus b. B stands for begin. Where is it that we begin? So we look at this equation, y equals mx plus b. We look at the equation we're supposed to graph. All we have is negative x. There is no plus b. So what should plus b be? It should be plus 0. And that is where we begin. We begin right at the origin, 0 on the y-axis. So we look at our y-axis, we're going to begin at 0. There is our point. Now, what would the slope be? This is going to be a tricky question because students consistently have problems with that negative out there. Now remember, the slope is the coefficient of x. So what I'm going to do is take a little diversion, trip down memory lane. Is it fair to say that negative 1 times 4 is negative 4? Is it fair to say that negative 1 times 6 is negative 6? Is it fair to say that negative 1 times 13 is negative 13? If it's fair to say all of that, well then let's say it the other way. Is it fair to say that negative 13 is negative 1 times 13? Is it fair to say that negative 6 is negative 1 times 6? Fair to say negative 4 is negative 1 times 4? Is it fair to say that negative 1 times x equals negative x? Is it also fair then to say that negative x is negative 1 times x? Of course it's fair to say all those because it's true. We know that to be true. So we come back to our example. We see that we have a negative x. Is it fair to say that this is the same thing as y equals negative 1 times x? So what will our slope be? The slope then is negative 1. So the slope of the line is negative 1. How cool is that? But remember, the B stands for begin, the M stands for move. How do we move a slope of negative 1? I need a rise over a run. I need a rise over a run. All I have is a slope of negative 1. Remember negative 1 as a fraction. Negative 1 over 1. I now have a rise. I now have a run. I am ready to graph. So, a rise of negative 1 from where I'm beginning, a rise of negative 1 means I'm going to go down 1. A run of positive 1 means I'm going to go to the right 1. So I began at 0, I went down 1, right 1. Here is my line. This beats making a table of 5 values, but all of those values are represented on the line. So now, what if we had equations that are not in slope-intercept form? So let's go back to our notes. What if we have equations that are not in slope-intercept form? So we have a couple of options. When we graph equations that are not in slope-intercept form, we have a few options. Well, 2 options actually. What we can do is option A, graph the x-intercept and the y-intercept. Remember how to find the x-intercept and y-intercept? So we would graph them. Option B, solve the equation for y, putting it into slope-intercept form and graphing it the way we just did. So when we have equations that don't look like slope-intercept form, we have a couple of choices. We can choose option A to find the x and y-intercept and graph that, or option B, putting it into slope-intercept form, working a little algebra. Here's an example. So the example I have is, what if we wanted to graph 4x minus 3y equals 15? This is not in slope-intercept form. So what do we do? What do we do? It's not in slope-intercept form. We'll call it option A. We're going to look for the x-intercept and the y-intercept. Okay, so if we're looking for the x-intercept and the y-intercept, remember that the x-intercept is when y equals 0. So we're going to make y equal to 0 and find out what x is. If we make y equal to 0, we can find out what x is. So we have 4x equals 15. Because 0 times 3 is 0, it just goes away. And then when we divide both sides by 4, we have x equals 15 over 4. So the x-intercept is actually 15 over 4, comma, 0. That's the x-intercept. We can actually graph this. The only challenge is, where on the graph would be 15 over 4? 15 over 4 is almost 16 over 4, which means this number is almost 4. So I'm cool with estimating stuff. As long as you put the point almost 4, 0, there's your x-intercept. For the y-intercept of the original equation, we make the x 0, and then solve for y. But here we have to be careful. 4 times 0 is 0, thus leaving us only with negative 3y equals 15. Then when we divide both sides by negative 3, y equals negative 5. So here I can have 2 points. Graph those 2 points on a coordinate plane, there's your line. You can graph it that way. You can also use option B. Option B, which was to solve the equation for y, putting it into slope-intercept form. We can also solve for y, put this into slope-intercept form. So here's more previous knowledge we learned on the last lesson. And remember, I am using some shortcuts now because I'm getting better at this. When I divide everything by negative 3, I divide everything by negative 3. Y equals 4/3 x. 15 divided by negative 3 is negative 5. Now I'm able to identify my slope and my y-intercept. So I'm going to graph this using option B, but I'll show you how we could have used option A. Here is our coordinate plane. So we have our coordinate plane. I'm going to graph this equation using our slope-intercept form. We begin at negative 5. Begin at negative 5 on the y-axis. We move our slope. We move our rise over run, 4 over 3. So that is up 4. 1, 2, 3, 4. Right 3. There's our second point. Here is our straight line. So we have graphed this equation using option B, which is to solve for y using slope-intercept form and graphing. Now what was option A? Do you remember what option A was? Option A was to graph the x-intercept and the y-intercept. Connect the dots. Let's see if that would have worked as well. Well, we know the y-intercept, that's where we begin for y equals mx plus b. Remember the question, where on the graph is 15 over 4? On the x-axis. On the x-axis, 15 over 4 is almost 4. Look at where our graph crosses the x-axis. So if you wanted to, you could have graphed the x-intercept and the y-intercept, connected the dots, we would still have the same graph. So we can do it that way as well. So whenever you see an equation that's not in slope-intercept form, you can graph using the intercepts, or you can graph using y equals mx plus b. I'm going to end on a tricky but simple note. What about vertical and horizontal lines? So let's do a refresher about vertical and horizontal lines. These are my favorite. So when we have vertical and horizontal lines, we need to remember what they look like. Vertical goes up and down like vertical blinds. Horizontal goes side to side like the horizon. What about slope? The slope of a vertical line is undefined. The slope of a horizontal line is 0. What about the equations? The equation of a vertical line, x equals something. There is no y. The equation of a horizontal line, y equals something. There is no x. These are all the things we know about vertical and horizontal lines. So we can graph them super duper easy. Here's an example. Let's graph the equation y equals 4. Remembering everything we remember, in this equation, y equals -4, there is no x. There is no x. So we know this is a horizontal line. It's going to be a horizontal line. There's no x. Excuse me. That means every ordered pair has a y coordinate of -4. So I'd have 0, -4, 1, -4, 10, -4, -3, -4. All of the y coordinates are at -4. That means on the y-axis, we're at -4. And we know this is a horizontal line. It's easy to graph. There is our graph. One more example. What if we wanted to graph the equation x equals 3? So once again, we're dealing with an equation. We're missing a variable. This equation has no y. If it has no y, it is a vertical line. A vertical line. And since we're missing the y, all we're saying is x equals 3. That means every ordered pair has 3 as the x coordinate. We have 3, 0, 3, 2, 3, 20, 3, -5. So all of the ordered pairs are on the same vertical line. We can graph that. Since it says x equals 3, on the x-axis we plot 3. We know it's a vertical line. We have a vertical line. And now we know how to graph. We know how to graph everything simply by looking at the equations. That is it for this unit. I wish you luck on our test.